Today we will mainly concentrate on impact. Yesterday we discussed the momentum impulse and little bit about work energy. In collision also concept is introduced. Today we will concentrate impact, collision and work and energy. Okay. The principle of this principle will apply for particle, point mass and rigid body. Okay. See now, let us see that is what the collisions, energy methods, energy formulations, etc., which you have to consider in the next. See the learning outcomes for today class are we have to represent express dynamics of a particle or a rigid body and differentiate between kinematics and kinetics. That is where we are starting our every topic when we are discussing dynamics. Because today we will talk about little bit plane motion also. Because the translation, rotation and plane motion. The plane motion concepts we are not touched much. Independently we have discussed the translation, rotation. But when we combine these translation, rectilinear translation plus rotation or curvilinear translation plus rotation, you will get the plane motion. We apply these concepts for different dynamic principles, Newton's law, Day-10 principle, momentum impulse, work energy, and then derive the expression for impact, collision, work and energy concepts, impact and collision. Represent kinetic equations for translation, rotation and plane motion of a particle and rigid body. The concept must be really understood by every student and applied to the physical systems. Updating knowledge of course as per need. Because if you understand the fundamental, then only you can apply for physical system, any problem. Static or dynamic problem, you have to update the knowledge from time to time, like ICT enabled tools, digital technology. If it is required, we are in a position to apply this. Now it is a part of kinetics, the collision as well as work and energy. Force acting on a body, the mass of a body and the motion of a body. These three we are considering. Mostly the motion is a non-uniform motion when you are talking about the actual dynamics. It is used to predict the motion caused by given force. Due to force, what type of motion we are getting. Here force is proportional to the acceleration. If it is a Newton's law, Day-10's principle. Whereas impact and collision, impact we try to represent in terms of time and velocities. In work energy we try to represent in terms of displacement and velocity. That is velocities, and that is how we are changing the concept. Same equation we are modifying. That's what I already explained. Type of force causing the motion. It will apply for rigid body or a particle. The type of motion is translation, rotation and plane motion. At the end of the class, we will talk about more in detail about the plane motion also. Okay. See, in mechanics, an impact is nothing but a high force or a shock. Yesterday we have discussed a shock load, sudden load. When you are traveling on a vehicle, if the speed breaker is coming, it is an impact. When two vehicles are colliding, it is an impact. The accident taken place between anything, tree and vehicle, or two vehicles collided, or it will hit the man, or it is hitting on two-wheeler or four-wheeler, or a heavy vehicle like lorry, bus, transport vehicle, etc. This is always the collision is taking place. At normal speeds, generally, during a perfectly inelastic collision, we are assuming, that is an object struck by a projectile will deform, and this deformation will absorb most or all of the force of the collision. Okay. So that is generally we are calling as a perfectly plastic, elastic and plastic cases generally will consider here. Then the most common use of word collision refers to the incidents in which two or more objects collide with a great force. Collision taking place with the maximum force with a small duration of time. See, that's what we are considering as a collision. Now, the scientific use of the term implies nothing about the magnitude of the force. All collisions will have a conserved momentum. The force is because equal and opposite, it will always cancel with each other. That's why nothing about the magnitude of the force, only the momentum is conserved, because we are considering a conservative system, which distinguishes different types of collision, whether they are conserved kinetic energy or not. Momentum is always conserved. That's why force is not playing much effect. But kinetic energy, whether it is conserved or not, depend upon the type of the system. That we will see when we are discussing some more concepts of collision. One more important point is here the collision concepts. The line of impact is the line that is collinear to the common normal of the two surfaces that are closest or that are hitting or that are in contact takes place. That is what we are calling as the line of impact. Line of impact, once again I am repeating, is the line that is collinear to the common normal of the surfaces which are closest or contact or hitting. This is the line along which the internal force of a collision acts during impact. This is not playing any much role because momentum we are assuming conserved. And Newton's coefficient, that is what we are calling as coefficient of restitution, is defined only along this line only. Coefficient of restitution. After hitting, there is a deformation and it is elastic. If it is regained, that's what. The before and after, if you divide the ratio, that is what we are calling a coefficient of restitution. Whereas an elastic collision is a collision in which there is no net loss in kinetic energy of the system as a result of the collision. There is no net loss in kinetic energy in the system. Both momentum and kinetic energy are conserved quantities. An elastic collision is a collision in which there is no net loss in kinetic energy in the system as a result of the collision. Both are conserved quantities. That's what. Here kinetic energy is also conserved. The momentum is also conserved. Whereas an inelastic collision is a collision in which there is a loss of kinetic energy because it is already gone into the hysteresis loop, that is otherwise here stress strain curve, force versus displacement or stress versus strain. If it is elastic, this is the diagram. This is the loading and this is the unloading. Depend upon the slope. Okay. But for plastic collision, it is taking place loading. This is the loading. For unloading is something like this. This is the tensile load and there is some loss of energy. Okay. That's what we are calling as the inelastic collision. Inelastic collision is there is a loss of here. There is a loss of kinetic energy while momentum of the system is conserved. Momentum is conserved, but kinetic energy is not. See, that is the difference between these two, elastic collision and plastic. Elastic collision, both are conserved, and here the momentum is conserved, the kinetic energy is not conserved. That is what is the one difference between the elastic and inelastic. Elastic and inelastic collisions. Here both momentum energy is conserved, here only momentum is. Sometimes is asking gate examination. What is the difference between elastic and inelastic collisions? Now what are the types? It is perfectly elastic collision, inelastic collision, perfectly inelastic collision. Okay, these are the three things generally we'll consider, but basic classification is perfectly elastic and perfectly inelastic collision. Sometimes perfect becomes the general inelastic collision. Okay. Specifically, collisions can be either elastic, that's what, or inelastic, plastic. Meaning they are conserved, and I already said both are conserved, here meaning they conserve momentum, not kinetic energy. This inelastic collision is sometimes also called as a plastic collision, or a perfectly plastic collision, also called as perfectly plastic collision, is a limiting case of inelastic collision in which the two bodies coalesce after impact. This one. That is what is the perfectly inelastic collision. The degree to which collision is elastic or is quantified by coefficient of restriction. This value is always varying between, this is the degree in which the collision is elastic or plastic. It is quantified by the coefficient of restitution along the line of action. A value that is generally ranged between 0 to 1. 0 or 1. A perfectly elastic collision, the coefficient of restitution is 0, this is 1, and a perfectly plastic collision, the coefficient of restitution is 0. Because here energy is conserved before elastic and after elastic impact is same, that's what is the 1. Here it is 0. After impact, the 0 means the ratio is equal to 0 means denominator is equal to 0. That is how we will consider the. So this is what is the collision classification. Once again I am representing perfectly elastic collision or plastic. Elastic or plastic. Generally plastic again in some conditions we call it perfectly plastic or inelastic. General case we are calling it the plastic or inelastic. So this is the basic classification of the collision part. Now types of collision. Here head-on collisions and non-head-on collisions. There are two types of collisions between the two bodies. Head-on collisions are one-dimensional collisions, where the velocity of each body just before impact is along the line of impact. Where the velocity of each body just before impact is along the line of impact. And non-head-on collisions is oblique collisions or two-dimensional collisions, where the velocity of each body just before impact is not along the line of impact. That's what it is. Just before impact is along the line and is not along the line, and the earlier one is one-dimensional and it is two-dimensional. That is the basic philosophy difference between physics of the problem. The types of collision generalized manner. According to the coefficient of restitution, which is acting along the line of impact during impact for elastic plastic. The two special cases. That's what the elastic collision is defined as one which there is no loss of kinetic energy. And anyway, momentum is always conserved. In reality, if you see the macroscopic collision between the objects which convert some kinetic energy to internal energy and other forms of energy. So, no large scale impact are perfectly elastic. Only small, that is in the elastic region only, it regain its original shape. However, some problems are sufficiently close to the perfectly elastic that they can approximate the coefficient of restitution equal to 1. In the For limiting cases, there is an exception, but most of the cases, if it is an elastic, we will consider the coefficient of restitution is 1. An inelastic collision is one in which part of the kinetic energy is changed to some other form of energy in the collision. An inelastic collision is one in which part of the kinetic energy is changed to some other form of the energy in the collision. Here it is a non-conservative system, that is what there is a loss in the energy. That's why kinetic energy is not conserved. Only momentum is conserved. When there is a loss, we cannot get 100%. Momentum is conserved, kinetic energy through collision, since some of it is converted into some other form of energy. In this case, coefficient of restitution does not equal 1. Okay, that is the difference between the elastic and plastic. In general philosophy, if you can observe here, in any type of collision, there is a phase when for a moment colliding bodies have the same velocity along the line of travel. After collision, they have the same velocity until some small duration of time. Then the kinetic energy of the body reduces to its minimum during this phase and may be called as the maximum deformation, of which momentarily the coefficient of restitution becomes 1. This is sometimes, this is very, very important when you want to derive the equations. Once again, I am repeating, if any type of collision, there is a phase when for a moment colliding bodies have the same velocity along the line of impact, then the kinetic energy of the body is reduced to minimum during this phase and may be called as maximum deformation phase, for which momentarily the coefficient of restitution becomes 1. We will see these cases when we are discussing. The collisions between hard spheres may be nearly elastic, so it is useful to calculate the limiting case of an elastic collision between hard sphere, that means heavy weight and maybe nearly elastic. The assumption of conservation of momentum as well as conservation of kinetic energy makes possible the calculation of unknown velocities when the two bodies are colliding. Now this is what I already mentioned: elastic, inelastic body, restitution, the coefficient of restitution, time of compression, time of restitution. See, that change in velocity ratio we are calling as collision. Sometimes the work force into displacement, the conservative, non-conservative. When the system is conservative, when it is non-conservative, kinetic energy, potential energy, law of conservation of energy, conservation of momentum, power. These are the parameters generally we come across in when the system is. That's why work and energy, momentum are a little bit interconnected when we talk about collisions. Now let us talk about the different types of motions: the translation, rotation, and the plane motion. Okay, that is rectilinear, curvilinear, rotation, and plane motion. These are the three areas where we are considering the impact, collision, and work and energy. If the change in momentum occurs over a short time, the force of impact is large. If the change in momentum occurs over a short time, the force impact is large. This is yesterday also we have shown. These are some of the examples. That is where other applications impact. But here, the Ft change in momentum, this F into T is equal to final momentum minus initial momentum. But if we can see these two, the relation is these two are directly proportional, these two are indirectly proportional with respect to velocities, with respect to time, because this is anyway constant. These are the other part of the collisions. This is also impact. This is not that much impact, but impulse, pulling or pushing. This is also another type of where the momentum is conservation of momentum principle come to the picture. With the conservative system, here in all cases, the conservation of momentum. When there is a collision, you can see the momentum is conserved, energy is conserved, or only momentum conserved, energy is not conserved. Depend upon that, we can consider the elastic collision or the plastic collisions. This is again before and after impact, how things looking like. Sometimes bounce back, sometimes captured. Okay. These are impulse moment relationships for this is the hard nature and this is the soft. Very hard, rigid. And this is not that much rigid. Because of this, see the difference between the two cases. This is a simple pendulum. There are 5 pendulums are acting, one touching over the other. If you can lift and hit, obviously you will get different types of motions. A curvilinear path you will get, or like a spline shape also will depend upon how the arrangement we are doing. Now let us see the law of conservation of momentum, where if the body moves along the straight line, the law of conservation of momentum can be written in the scalar form m1 v1 plus m2. That is, initial momentum is equal to final momentum. Initial velocities are v1 and v2, and let us say final, or vice versa. The notation is your choice. And angular momentum is this. This is the body in translation. This is the body in rotation. Initial momentum is equal to final momentum. Here one body, 2 bodies. I1 omega 1 plus I2 omega 2 is equal to I1 omega final 1 plus I2 omega 2 final. This is the initial and this is the final. This is the linear rate of change of momentum. Force, Newton's second law. It is momentum is equal to rate of change of linear momentum. That is the angular momentum. Rate of change of linear momentum, rate of change of angular momentum. This is the body in a translation, this is the body in a rotation. If you can combine both, the body in a plane motion. Okay? So this is now generally we consider the case of when the body in a translation or when the body in a rotation. Now see, 2 smooth balls A and B approach each other such that their centers are moving along the line, that is along a particular line. The absence of external force, I already mentioned, the forces are always impact equal and opposite, that is not playing much role. Let the velocities of A and B just before collision be U1, U2 respectively, and the velocities of A and B just after collision will be V1, V2. That is V1 less than V2 and here U1 greater than U2. That's what as per the numerical data. That is the case we are concerned. Assume that the numerical data is in such a way U1 is greater than U2, V1 is less than V2. During one is say the deformation stage and the reformation. This ratio we are calling as the coefficient of distribution. So the linear momentum is conserved initially m1 u1 plus m2 u2. At certain after hitting together moving some duration of time, that is m1 plus m2 with a common velocity. After that m1 v1 plus m2 v2. Because the size is very small, the size is very big. Accordingly, it can move and depend upon the velocities also. Now from this, because these are known quantities, if this is the case, if after impact also together they are moving, I will show the cases. When you are firing a bullet, it will be in the body only. It together moving a common velocity. That's what the case. In that case, the linear momentum is equal to m1 u1 plus m2 u2 by m1 plus, or these two you can equate. m1 v1 plus m2 v2 by m1 v2. Then the impulse of deformation is this relation m2 v minus u2. That's the change of momentum. And u1 minus v. u2 v minus u2 and u1 minus v. See, this is the ratio what we will consider the impulse of deformation. This is final velocity minus initial velocity. Okay. Final velocity minus initial velocity. The coefficient of the restitution calculate, we need a deformation and reformation. This is what is the deformation. And reformation is the change in momentum in a one body during deformation. That is V2 minus V and V minus V. This ratio V2 minus V, V minus V, impulse of reformation and impulse of, that is with respect to the velocity V2, this is the ratio, and with respect to velocity U2, this is the ratio, or with respect to other one also, in terms of V1, V also consider during deformation and during reformation. So this ratio, this V, already we have calculated, we substitute and determine the coefficient of restitution. Okay, velocity of separation along the line of impact, velocity of approach along the line of impact. This ratio is called a coefficient of restitution. It is equal to 1 for elastic, it is equal to 0 for plastic. But in between also you can select, depend upon the type of condition. See, momentum, why we will bother about is sometimes momentum is conserved, energy is not conserved, or both are conserved. Kinetic energy combined with gravitational potential energy can help to solve many types of problems in many situations, circumstances. So collisions is very important, able to figure out what's going on to happen when objects collide, and simply energy method usually don't work. Okay. We need the momentum, other principles. So now let us see, angular momentum is equal to I omega. Differentiate with respect to time as per now. I into, which is constant mass moment of inertia, d omega by dt. That is alpha. That is dl by dt is equal to alpha. Since there is no external torque, if suppose the momentum is 0, then this is equal to 0. Then if you integrate, L is equal to constant. So the answer is true. That's how we will consider the angular momentum. Okay? The concept of angular momentum is momentum, the energy momentum is conserved or angular momentum is conserved. Earlier linear momentum is conserved. Now angular momentum. I1 omega 1 plus I2 omega 2 initial and is equal to I1 omega 1 final and I2 omega 2 final. This is how generally we consider the case. So this is what the before collision at the point of maximum deformation and after collision. If you can see here, coefficient of restitution is VB dash minus VA dash and VA minus VB, depend upon sign convention. The relative velocity B with respect to A after impact and before impact. That's what is called the coefficient of restitution can be defined. See, now the impact sometimes will classify depend upon the line of. See here the two types, central impact or oblique impact. Earlier head-on collision, that's what we have, that is one type of classification. When the two bodies are collide, causing impulsive force or impact, except by the bodies. Like examples of sting of a hammer on a nail, golf club on a block. When you are playing a cricket, your bat hitting a ball. When you are playing volleyball, when your leg is hitting a ball. When you are playing a volleyball, your hand hitting a ball, and football, when leg is hitting the ball. Any game, if you can consider, when long tennis, when you are hitting a bat, hitting the ball with your hand. Here sometimes the impact is this type, central impact. Along line of impact, the velocity is also possible. Or oblique impact. It is not along the line of impact traveling in different direction. But at the line of impact, one point it is impact. This is what we are calling as the plane of impact. In which plane the impact takes place is called the plane of impact. It is a central impact or oblique impact. Generally, we will consider two types of impact: central impact or oblique impact. When the motion of one or both of the particles is at an angle with the line of impact. That is the difference between the central impact and oblique impact. In any case, see, the oblique means not along the x-axis. At any angle you can, but the impact is taking place along the line of action, line of impact. Collision between two bodies which occurs during small interval of time in which line of impact is common normal to the surface of contact, common normal. Central impact. Oblique impact is impact with mass center of two bodies. Otherwise, it is eccentric impact. Sometimes impact is mass centers are not hitting. Suppose simple pendulum hitting a ball like a bullet. It is eccentric because the end point is the same. The centroid is somewhere else and you are hitting. So that's why sometimes central impact, direct impact, oblique impact, direct central impact, two mass centers as well as velocities along the line of action, movement along the line of action. But here, the velocity is not along the line of action, this is the oblique impact. The center of gravities are not lying around this, is the eccentric impact. So like that we can classify some other classification of impact. See, these are the cases if you can see. When a bird hitting the aircraft, when the aircraft is traveling from 600 miles per hour, how do you make a reasonable estimate of these parameters involved? How much impact of force taking place? Here the impulse force is the average force into time interval into m into delta. This number of times you derive force is equal to rate of change of momentum m into dv, m into v in bracket d by dt. See, this is what is called the eccentric impact. This is the one body and this is another. With reference to this, it is oscillating. After impact, it will absorb together moving. This is what is the height, change in height. This minus this. Whatever the angle, L minus L cos alpha. That is your H, this H value. You find out. And this is what we are calling the eccentricity. Here what is called the before, this is the line of impact, this is the plane of impact. Initial velocities are these two, not along the line of action, this is the oblique impact. After impact it is moving away. Before impact this is the duration when this is greater than, otherwise impact if it is less than this there is no question of impact. So that's why to satisfy that one speed must and should be same as the other. So during impact, together moving, after impact, the body which is hitting higher velocity will reduce, the body which is moving lower velocity will gain the velocity. That is the general the impact principles which we are using. The oblique impact, so this is again the same thing, a collision. Two bodies which occur very small. This is already defined, only I am showing number of examples. This is moment before impact, moment after impact, M1, E1 we already mentioned. This principle is called the conservation of linear momentum. And this is what is the coefficient of restitution. Sometimes we'll put in negative sign also. That is V2 minus V1 can be represent minus you take outside for the direct collision. This is either plastic 0 and elastic 1. Okay. In another form also, see before and after impact. Before impact separately, after impact together it is moving. The final velocity of A, final velocity of B, initial velocity of A, initial velocity of B. If we can write that, the coefficient of restitution can be represented. Okay. So now let us come to that is what is called the collision part. See, once you can again recollect, as for the collision is concerned, the collisions are basically elastic collision, perfectly inelastic, perfectly elastic collision, inelastic collision, perfectly inelastic collision, or plastic. Then types are head-on collision, along the path, or head-on collision, some not along the line of impact. Based on that, we will classify direct, central direct impact, oblique impact, or eccentric. These are the cases what we have considered. But any type of impact, one parameter we are calling is coefficient of restitution during the impact along the line of action, before impact and after impact ratio. That can be determined for elastic as well as plastic. In elastic case, coefficient of restitution is 1, and in plastic case, coefficient of restitution is 0 we will consider. And whereas in elastic, both momentum conserved, energy conserved, but whereas in plastic only momentum is conserved and energy is not conserved, because it is not a conservative system. There is some loss of energy takes place. Okay. So this is how we will consider the translation phase, rotation case, and the plane motion means you combine the translation and the rotation. So this is how we have considered the collision part. Now let us see work and energy. For again 3 types of motions: translation, rotation, and plane motion. Okay. The translation can be rectilinear and curvilinear, rotation, and the plane motion. Now the basic definition is the force into displacement along a particular direction, which we are calculating. Here along the x-axis, the force actually making an angle theta, resolve f cos theta, f sin theta. F sin theta is not doing any work because it is body is moving in horizontal direction. There is no vertical displacement. If there is no displacement, no work done. So that's why work done is equal to force into displacement. If you resolve the force, this is f cos theta and this is f sin theta. There is no, the body is moving in this direction. This is the initial position. This is the after displacement delta r. This is the final position for a finite displacement. Now here, this component is not doing any work done. It is 0. There is no displacement. The work done is only takes place along this, the force into displacement R, or a delta, small vertical displacement. Now consider the Fr cos theta. Okay. This is how generally we will consider the cases. Fr cos theta, and solve the problems. Now let us see the case, the vacuum cleaner, house cleaning, etc., the grass cutters. This is the force he is applying. Resolve f cos theta, f sin theta, and find out the work done. Force into displacement. Okay. When you are holding a bag the force is acting upwards. The distance in this direction 0 because the force is acting in this direction. Here the force is acting in this direction because 90, distance 90, there is no work done along this. With reference to him, there is a work done. Now if you can see how Newton's law is, how the work is derived. This is the basic philosophy we are using. Simply it is a modification of Newton's law. That is one thing we have to keep in mind very carefully. Whether it is a momentum impulse or work and energy, which we can consider F is equal to ma, mass into dV by dt into ds. This dV by dt which can be rewritten as ds by dt into dV. Okay, work done is equal to this Wt if you multiply both sides. So here what I have written A into ds. Okay, A into ds. A is dV by dt and ds. dW mv, this is what we are calling as the acceleration. Both sides are multiplying ds. Fds is equal to ma into ds. This force into displacement is work done, we already defined. Ma into ds. The acceleration is dV by dt. dV by dt can be into d, this I am shifting here. ds by dt into dV. Okay. ds by dt. M ds by dt into dV. And integrating both sides will get 0 to W and Vu of m square. This is what is called the work energy. 1 minute, dear students. Oh, madam. Okay. Scrutiny అయిపోయింది. గ్రేడ్ స్టూడెంట్స్ కి దేనికి కాకుండా దేనికి వెళ్తున్నారు ఏదో స్థానాల్లో అక్కడ చేంజ్ చేస్తారండి. అదే ఎక్కడ ఉందండి ఆన్లైన్ అలా చేయించు సార్. సార్ అలా చేయడానికి పర్లేదు సార్. ఏంటంటే కొంచెం గవర్నమెంట్ కాలేజ్ వచ్చింది కాబట్టి కొంచెం గవర్నమెంట్ కాలేజ్ వాళ్ళకి ఎలా సార్ మరి పేరెంట్ ఆ విధంగా ఆలోచిస్తారు కదా.
private కి కట్టేయాలి గవర్నమెంట్ కి వచ్చేస్తారు డాక్టర్ శ్రీధర్
See here, what we have to do is the work energy or a momentum impulse. These are the modification of Newton's second law. Simply, you have to modify in such a way you will get the work energy. It's a simple derivation. Multiply both sides by displacement. The force into displacement into MA into displacement. Here work done can be represented as force into displacement, and acceleration can be rewritten as dV by dt. Okay. This dV by dt can modify as ds by dt. This ds you move here, dV. Then this is the equation. We can rewrite dW is equal to m into ds by dt. Now this is the velocity. Now integrate both sides, and because it is you make the boundary conditions, the initial work done, final, and initial velocity, final velocity. So this is how we will represent the final kinetic energy, initial kinetic energy, and this is the work done. This is what is called the principle of work energy. It's simply a modification of Newton's second law. Suppose an electrical generator. Okay, when it is rotating a rotation, when the body moving on steps, the force component you resolve in the x-axis and y-axis are along the plane and perpendicular plane. Find out the work done. Because here, if you can consider a force along the plane, the work done along the plane is a force into displacement. Perpendicular to the plane, there is no work done. Why? Because there is no displacement. Now let us take a small spring. Any system can be represented as a flexible nature. This is when the displacement zero, when it is hitting with your hand or directly hitting, there is a deformation. Okay. So this is what is the kinetic energy. W is equal to half m square. This is the energy stored in the spring, half kx square. And if you can see here, as you go on, object is moving, the potential energy changing, kinetic energy also changing. Then the energy transformation is taking place. When you want to hit this surface with this, or when a body is moving in a curved path, here the maximum kinetic energy, here maximum potential energy. In between, something loss and something gain. Okay, so this is how generally we try to represent the system. This is what finally, when the body in a translation, net is of m square, final work done is equal to the kinetic energy stored in the system of m square, or Vf square minus Vi square. So this is what is the energy and work. Kinetic energy, work done by a force. Work, kinetic energy, Kf minus Ki. We can represent the work done, force into displacement is equal to the energy stored in the spring. If you can equate both. Now for a non-conservative or a conservative system, you can like the energy stored in the spring or energy stored due to gravity forces or of mvf square m square. These are the things generally we consider. The work energy theorem. Or see, this also can be modified in another way. Mass into, you know the equation of acceleration, v square minus u square is equal to 2as. From that you determine m into a. This again modify Now, to obtain the work done, you have to multiply with the displacement. These two will be cancelled. Now, finally, initial kinetic energy, final kinetic energy. So, this is what is the change in kinetic energy we can get. The same thing, the relation finally can be represented like this, the net work done. If it is a force not acting along the line of action, some inclination F cos theta of m square of mvi square, you can write in such a way that the kinetic energy plus potential energy, the total energy is constant. This is mgh mv square. Okay, the kinetic energy and potential energy, the total mechanical energy, which is constant, initial and final under the conditions. If it is a spring, kx dx, kx is that is a spring force with respect to displacement. If you can equate, you will get the energy stored in the spring is half kx simply by integrating. So this is what is the change in kinetic energy. Final kinetic energy minus initial kinetic energy. Just now I derived the expression. The same thing, initial, the expression, this is what is the work done. Final kinetic energy, initial kinetic energy. When an inclined plane, if you can resolve the force, this is the gravity force, this is the force applied, and this is the normal force, and the frictional force is there acting opposite. This is when you are lifting a weight to aircraft, to cargo vehicle, or a trolleys, etc. This type of principle is considered. Now, similarly, this is the same thing what we derived here from V square minus U square to AS, you can get and substitute. Finally, we get this in the equation. Now, it is a vector notation. Earlier, it is a scalar notation. It is a vector. F is fxi, fyj, and fzk, and displacement is dxi, dyj, dz. If you make a dot product of the two, f dx, f dy, and f z dz, the total work. Now, what are the forms of energy, sir? Electrical energy, thermal energy, light energy, or green energy, wave energy, heat energy, or hydroelectric energy when there is a hydraulic plant, power plants, tidal waves, nuclear energy, wind energy, solar energy, biomass energy, kinetic energy, geothermal. These are the energies generally we come across, work and energy principle. Any of these cases, this principle can be applied. Okay. The principle of work energy is again this part is when there is a component in the x direction and yes. This is what is the energies we will consider: sound energy or light energy, etc. See, this is what when there is a force, velocity 0, final velocity, the difference occurs. This is a simple problem. A solid sphere of mass 45 kg is rolling along a straight line at a speed of 6 meters per second. What is the magnitude of work done? We have to calculate. This by using this R by omega square, the sphere is having moment of inertia 2 by 5 mr square. V is equal to R omega. If you can consider, now we will get the kinetic energy stored in the system. This is again when the body is moving in an inclined surface. You have to resolve this is another problem. The kinematic initial velocities are given. Acceleration is constant. You find out the acceleration. Then work done. F is equal to ma. Force calculate. Then work done is equal to force into displacement. Here three things. So when force and displacement are in the same direction, both are positive. If both are in the opposite, it is a negative work done. If it is a perpendicular, here both are parallel, but one is opposite to the other, one is parallel with each other. If both are perpendicular, then the work done is 0. These are the three cases generally we come. We will close today's class because I have some other meeting today. And tomorrow we will try to discuss the plane motion and the center of gravity, center of mass, moment of inertia. These are the things we will try to concentrate tomorrow. And today, with this, please send your any queries, questions through Google Forms regarding what we have taken till now 10 classes. Somebody already we have received, but more people can send your Google Forms. We will give a reply for all your queries. Okay, thank you very much for your patient hearing. Please try number of problems. If you have any doubts, you can ask and interact and send through Google Forms. I have a meeting. Again, we'll meet tomorrow at 10:30. Thank you very much.